waveguides, which is a transmission line only for, as I said, only for high frequency, high power application. Why we are using waveguides only for high power, high frequency application? Because it's very big in size, difficult to connect for installation. It's very expensive. So the application is only limited for high power, high frequency applications. Why we need waveguides? Because other two conductor transmission lines, like twisted pair or coaxial cables, when you go to high frequency, they are very, very lossy, too much attenuation. That's why microwaves comes to picture. It has minimum of loss, minimum attenuation at very high frequency and power. But there is also one limitation with waveguides. What we call it cutoff frequency. Two conductor transmission lines like coaxial cable, they don't have cutoff frequency, which means you can transmit, start from zero frequency, you can transmit through coaxial cable, but these waveguides, they have a limit, not the maximum, but minimum frequency limit. So this cutoff frequency depends on the size of the waveguide and the type of propagation mode you are using. Depends on this. Every waveguide has a cutoff frequency, a minimum allowed frequency. Below this frequency, the signal will not be transmitted. It will be rejected by the waveguide. It will be reflected back. But above this cutoff frequency, the signal will effectively transmitted with minimum attenuation. That's very important point about waveguides. In terms of structure, there are two types of waveguides. It can be rectangular waveguide, as you can see on the slide. This is a rectangular waveguide. In some cases, in many applications, you will find waveguides with circular structure. So it can be two types, rectangular and circular in terms of structure. But fiber optic cable also named as waveguide, but it is called dielectric waveguide, which is used to guide light from source to the destination. Light in fiber optic communications guided through this fiber optic cable. So the fiber optic cable also used to guide light from one point to another point. It's also called waveguide, but it is dielectric waveguide. But when you come to microwave, we are using metallic waveguide, not dielectric waveguide. It's made up of metal and it is hollow inside. So it's hollow metallic pipe. When we define waveguide, it is a hollow metallic pipe for guided wave propagation. That's how we define waveguide. Waveguides here are hollow inside. There is nothing. There is no dielectric material. There is no internal conductor. We have only the outside external conductor. So because of this, okay, so for hollow, because waveguide is a hollow structure, it does not support TEM mode, which is what we call a transverse electromagnetic mode. Both electric and magnetic field are perpendicular with respect to the direction of propagation. We call it TEM mode. In order to transmit TEM mode, we need field conductors like coaxial cable and so on. But if it is hollow pipe like waveguides, it only supports either TE, transverse electric, or TM, transverse magnetic modes. I will explain you later in detail what's TM mode. Okay, Safia, can you hear me? Abdisalan, Ahmed.
No one is okay.
Yes, yes.
You hear everything? The sound is good?
Okay.
Yes.
Good, good.
Okay. So we'll
Teacher,
yes.
hollow, what this means? Hollow.
Hollow, there is nothing inside. When you see a coaxial cable, what you see inside is a dielectric material, right?
Yeah.
When you see a coaxial cable, internal there is a material, what we call it dielectric material, this white one, Teflon, and internal conductor. It's not a hollow like a water pipe. When you see a water pipe, inside it is a hollow, right? So the water flows through the
Yes.
this pipe. It's hollow. There is nothing there. Just like that, for coaxial cables, it is filled with dielectric material. It's not hollow. But waveguides, we have a metallic structure on the outside, but internally it is hollow. There is nothing there, only air. So the wave, our microwave is guided through the waveguide from the source to the destination. Because it is hollow, the type of propagation mode which is supported by waveguide is only either TE or TM mode. TM does not supported by waveguide. To transmit TM mode, we need what? We need two conductors, one internal like this, one external, separated by some dielectric material. So in this case, we have TEM mode of propagation, which means the electric and magnetic field are perpendicular with respect to the direction of propagation, what's called TEM mode. It's very important to understand these propagation modes. I will come to another lecture. But here I want you to understand 3 important points about waveguide. First, how we define waveguide. It is a transmission line, metallic hollow pipe, which used to guide our microwave signals from one point to another point. And why we need it? Because other cables like this, in this case, how many conductors we have? 2. Inner and outer conductors separated by some dielectric material. But when you come to waveguide, we have only one conductor, the outside. Internally, it is a hollow structure. It's only air. It's one conductor system. But in this case, how many? It's 2 conductor system. When you see twisted pair, how many conductors? 2 conductors, right? Twisted each other. If you see parallel line, transmission line, also 2 wires. But in waveguides, we have only the outer metallic structure. Internally, there is nothing. It's a hollow pipe. Its applications, it can be used for 3 applications. You can find high pass filter. Waveguides can be used for filtering purpose, not only transmission. It's also used to reject some frequencies. Okay. Another application, we can use it as transmission line. Another application, we can use it as antenna. Sorry. So as I said, one of the important advantage of waveguides is when we see the diagram last time. This diagram, do you remember?
Yes.
We use this diagram to select the best cables, right?
Yes.
to select the best cables. Cable 1 to 3, 4 are coaxial cables, 5 up to 12 waveguides, and number 30 microstrips. So when you go to high frequency, waveguides has a minimum attenuation. Coaxial cables, they have very high attenuation at high frequency. So that's why waveguides comes to picture. Okay, but what's the disadvantage of waveguides? They are very big in size, as you can see in this radar air traffic control room. We have a waveguide, rectangular waveguide, which is very huge in size, right? Waveguides are very huge in size, very expensive, difficult for installation. So their application is limited only for high power, high frequency applications. And another important point what we have discussed today is all waveguides, they have what we call it cutoff frequency. So what does it mean by cutoff frequency?
To separate unwanted.
Yes?
Or to separate unwanted frequency.
Cutoff frequency, when you see coaxial cable, coaxial cables, it says what? Coaxial cable, it has no cutoff frequency and can be used from DC, which is 0 frequency, to what? Sorry, there is a... Can you hear me?
No one, it's okay.
Okay. I don't know why I cannot share. Okay. So I'm explaining cutoff frequency. So coaxial cables, as you can see here, they don't have any cutoff frequency, which means you can transmit start from what? DC. DC means zero frequency. Zero frequency. Minimum zero frequency. DC signal you can transmit through coaxial cable. No problem. No minimum limit. Up to what? Up to 50
gigahertz.
gigahertz. You can transmit this frequency range. It starts from 0. But waveguides, they have a minimum limit. So if you have a waveguide with cutoff frequency 2 gigahertz, it means what? It only transmits above 2 gigahertz. Only signal with frequency greater than 2 gigahertz will be transmitted. But any signal with frequency less than will be reflected or rejected by the waveguide. That's what we call it cutoff frequency. Do you get it?
Yes.
Okay, any other question? We can discuss if you have any point.
What's the disadvantage of waveguide?
The main disadvantage of waveguide is its size. Waveguides are very big in size, it's heavy, and it's very difficult for installation. I will show you a video. Let me share a video. Have you seen the video?
Yes, yes.
So he is connecting waveguide, circular. In this case, you can see it is a pipe, right? But it is circular waveguide. He is now connecting, okay? connect. So connection will be very difficult, as you can see here. It's not easy installing a waveguide cable to the antenna. It takes many processes, as you can see.